Hi guys, we're on the last example for 5.4. Finally, woohoo! This has been a long one, but remember you can do it over 2 days. So page 289, number 28, last challenge question. We need to solve the equation cos x over 1 plus sine x plus 1 plus sine x over cos x equals 2 on the interval x is an element of negative 2 pi to 2 pi. I'm getting used to this stylus now, sort of. It's pretty tricky, but it's kind of neat too at the same time. Okay, so we need to obviously simplify that left side a little bit, because right now it looks like there's no way we can get one trigonometric function isolated. And so we should think back to our tools for solving trig identities. If we have multiple terms on one side and only one on the other, then what should we do? Get a common denominator. So let's start by doing that on the left-hand side. Common denominator is going to be cos x times 1 plus sine x, because they have nothing in common, so we just multiply them together. And then we need to multiply the first numerator by cos x, because that's what it's missing, so it becomes cos squared x. Multiply the second numerator by 1 plus sine x, because that's what it's missing in its denominator, which is 1 plus sine x all squared. Make sure you have the bracket around it, so that you don't get confused and think it's only the sine that's squared. And all that is still equal to 2. Okay, at this point, let's just go ahead and expand and simplify the numerator and see if if that helps to simplify anything. Because right now it just looks like a big mess. So cos squared x, I'm going to expand and simplify this bracket over here. And remember the shortcut for doing that, which is square the first term, multiply the two terms together and double it, and square the last term in the bracket. And let's just keep the denominator the way it is and not expand it, because we want to see if perhaps at some point we might be able to reduce something. So don't expand the denominator. On the top now, if you take a close look, you will see that we have a convenient identity that we can, no, I wanted a different color there, hang on a minute. Okay, let me get my pink. That we can replace. We have cos squared x plus sine squared x, and we should all quickly and easily at this point recognize that to be equal to 1. So let's replace that. Okay, and then obviously 1 plus 1 is 2. So let's go to the next page and write it as 2 plus 2 sine x over, leaving the denominator the same still, do not expand it, cos x 1 plus sine x equals 2. Now, if we remember that I said we left the denominator not expanded to see if we possibly might be able to reduce something to try and make this a little bit simpler. And if you look at the numerator now, then hopefully you will see that we can common factor out the 2. Which will give us 1 plus sine x on the top, and lo and behold, I don't know if you guys know that saying, it's a little bit old-fashioned, but as I always tell you, I'm kind of old, so sometimes use old-fashioned sayings. 1 plus sine x on the top and 1 plus sine x on the bottom. Let's cancel them out, or reduce them is more proper language for that. Okay, so then we now have 2 over cos x equals 2 equals 2. Why not divide out the 2's at the same time? So now we have 1 over cos x equals 1. And what is 1 over cos x equal to? Secant x. So let's replace it right away. Oh, hold on a minute. That was the wrong thing to do. Why? Pause me and answer that question. It was the wrong thing to do because I can't solve it directly from secant x, so I need to change it back to cos x anyway. I'm going to do that here, and then I'm just going to cross multiply, which gives me cos x equals 1. So cos x equals 1, so again, I just want to clarify that this step here was not useful, was not a good step to do. And so that's why I just reversed it again. And the reason it was not a good step to do didn't get me closer to where I want to go, which is what we should always be asking ourselves with identities and trig equations. So cos x equals 1, again, that's going to be on my unit circle. First coordinate has to be 1, so that would be over here, 0 or 2 pi. And just as a reminder, our domain that we're working with here, our interval, is negative 2 pi to 2 pi. So is there another angle in that domain that for which the cosine of that angle is also 1? Yes, it would be negative 2 pi. So that's also an answer. So therefore the final answer, x equals negative 2 pi, 0, and 2 pi.